This chapter is on the reactions of carboxylic acids and its derivatives. Carboxylic acids and its derivatives have got an important functional group called as the carbonyl group. The compounds that contain this carbonyl group are said to be carbonyl compounds, and they are found abundant in nature, and many of them play many important roles in biological processes. An acyl group is a group where the carbonyl group is directly attached to either an alkyl group or an aromatic ring structure such as the benzene. Now, the carbonyl compounds can be divided into two different categories, depending on the group that is directly attached to the acyl group. So if Z is going to be an atom that is more electronegative than carbon, it falls under the first category. And if Z is going to be either an alkyl group or an aryl group or hydrogen, then it's going to fall under this second category. Now let's see what are the compounds that fall under these two categories of carbonyl compounds. Let's draw the general structure. So the general structure of the carbonyl compounds is going to be like this. Now, if the Z is going to be a group or atom that can be replaced by another nucleophile, then it's going to fall under the first category. So here are the compounds that's going to fall under the first category: carboxylic acid, ester, acid chloride, amide, and substituted amides. All of this is going to fall under the first category. And in all of this group right here, these highlighted groups can be replaced by another nucleophile. These compounds are collectively called as carboxylic acid derivatives. Now, in the next set of compounds, the Z group cannot be replaced by any nucleophile. Both carbon and hydrogen have about the same electronegativity, because of which this bond cannot be easily broken, right? And it is said to be more basic. And similarly, if you consider this as an R group, definitely we can imagine that this is connected to carbon again. So again, this is going to be basic, and because of which you cannot get it substituted by anything else. And there are two main compounds under this categories. One is an aldehyde and the other one is a ketone. The class to which a carbonyl group belongs depends on the basicity of the groups that is attached to the acyl groups. So here are the groups that are attached to the acyl groups. In the case of acid chloride, it's going to be Cl minus. In the case of ester, it's OR minus. And in the case of carboxylic acid, it's OH minus. And in the case of amides, it's an NH2 minus. Let's take a look into the conjugate acids and compare the pKa values. In the case of acid chloride, since Cl minus is the leaving group, the conjugate acid is going to be HCl. And we know that the pKa value of this HCl is going to be -7, which means it's a strong acid. So if this is going to be a strong acid, then definitely this is going to be a weaker base. A weaker base can be easily substituted by a stronger nucleophile. So therefore, this can be substituted by something else. Whereas as you go down the group, the basicity of this group is going to get increased, and therefore it is not going to be much easier to get it replaced by something else. Similarly, if you take the aldehydes and ketones, the leaving group is going to be either H minus or R minus. And the conjugate acid is going to have a high pKa, which means it's going to behave as a weak acid, and therefore this one right here should be a strong base. Because of which these groups right here cannot be replaced by nucleophiles.